Hello KG5, this is Mr. K. I'm going to talk to you about the Triple Science Year 10 rotation test. Hopefully you enjoyed all those extra science lessons, given that you have chosen Triple Science and you're thoroughly enjoying it and you're being really scienced up. So, question 1, part A. What two types of particles does part A contain? So it's talking about part A, which is labeled in the diagram. Now, given that electron is already labeled, there are only two other particles present. And if you brought a pen to class, you should be able to remember them. So the proton, the electron, and the neutron. And the two which are missing are obviously the proton and the neutron. These form in the nucleus, and so your answer worth 2 marks here is the proton and the neutron. How many electrons are in one atom of magnesium? For this you needed to look at the periodic table, and if you looked at the atomic number, this would also be the same as the number of protons, which is then also the same as the number of electrons, which is 12. This only works if it's uncharged, okay? So it's an uncharged atom, not an ion, so the protons are going to balance the electrons, so it will be 12 from the periodic table. Write down the electron arrangement for an atom of magnesium, and this is 2 electrons in the first shell, 8 electrons in the next one, and 2 in the final one, and you'll notice this totals 12, leading on from the previous answer. Next question, use the diagram and your answer to part B, so you're going to use the previous answers, to answer the following question. In which group of the periodic table is magnesium? Now the group is defined by the number of electrons in the outer shell, so it is of course group 2, given that the last number of electrons was 2. Explain your answer, and you're just looking for 2 electrons in outer shell. Use the periodic table to write down the electron arrangement of calcium. Now, similar style to the magnesium one. In fact, calcium is just one group down, one period down in the same group as magnesium. So this is 2. So this would be 2. Pen's going a little weird here. 2, 8, 8, and then 2. Okay. Next up is chlorine, and this following the same suit or the same style. This is 2, then 8, then 7. Let's make that a little bit clearer. 7. And the reason for this is what you're essentially trying to do is represent the electrons as if they were in an orbital diagram. So there are 2 electrons in the first shell, 8 electrons in the second, and 7 electrons in the third shell. Okay, hopefully that makes sense. Okay, this next question, part B. If calcium is heated and put into a glass jar of chlorine and a violent reaction takes place and solid calcium chloride is formed, the reaction proceeds due to the transfer of electrons. Use the electron arrangements and the idea of electron transfer to explain how the reaction between the atoms of calcium and chlorine takes place. So, top tip, always underline the chemicals involved. That way you're not going to get confused. Okay, and what it's actually asking, so you're trying to explain how the reaction between the atoms and of chlorine and calcium takes place. So, first up, why do atoms react? And this is going to be an ionic reaction, but why do they react? And the idea is to obtain a full outer shell. So what we can put here for the first mark is atoms obtain full outer shell to become more stable. Then we need to identify where the transfer of electrons is taking place, because it does specifically ask you about the transfer of electrons in the question as well. So the transfer is calcium will lose 2 electrons, and chlorine, and each chlorine will gain 2, or gain an electron, sorry. And then for the final mark, you just need to say electrons transferred from calcium to chlorine. You could have also done an electronic diagram for this, and for that you would essentially I'm just going to show you the full outer shells. So if we had calcium, okay, and it's got 2 electrons in its outer shell, and then we've got chlorine, and they have 7 electrons in their outer shell. We can show the transfer of electrons using a diagram like this and an arrow. So this electron here goes to there, and this electron goes to there. Okay, you could then follow up that diagram with the final ions. So for this you could, let's stick with the original colors. So chlorine was green, wasn't it? So that's got 7 of its own electrons, and then it's got 1 of the calcium electrons, and because it's got an extra electron than normal, we're going to give it a negative sign. Okay, and then we're going to have a positive, 2 positive calcium, because it's lost its 2 electrons. Okay, they're no longer present, and obviously there is then another chlorine looking exactly the same as the one I have just drawn. Okay, there's a diagram view. Next question, explain calcium chloride is a solid at room temperature and has a high melting point. Explain why calcium chloride has a high melting point. And for this question, what you're trying to find out is the type of bond present, which then will help explain its melting point. Now it's worth 2 marks. So the first mark is to say calcium chloride has strong ionic bonds. Ionic bonds. And the second mark is to say they require lots of energy to break. And just as a top tip, this second mark here, always put this if you've identified a strong bond. Okay, it was pretty much always worth a mark, and it could count up to maybe 3 marks in your actual GCSE paper of just writing that stock statement of they require lots of energy to break. Okay, moving on to question 3. This is about diamond and graphite. So what is the name given to the type of bond in which electrons are shared? So this is covalent, the sharing of electrons. Diamond is one of the hardest substances known to man and is used on the edges of glass cutting tools. Explain why the structure of diamond makes it so hard. Again, this is 2 marks, and the structure is related to its bonding. So there are strong covalent bonds, and I'm going to even prove this sentence by writing the word many beforehand. Many strong covalent bonds, and then put require, just like I told you before, lots of energy to break. So already in this test, that stock statement has given you 2 marks. Okay, remember it. Explain why the structure of graphite makes it soft and slippery. So for this one, let's get my pen back up. So atoms are arranged in layers, as we can see in the diagram, which is already shown for you. So there's a layer and there's a separate layer. These can slide over one another, and atoms are arranged in layers, and yeah, exactly what I just said. The second mark would be these layers can easily slide over each other. And the final question, part C. Diamond is an electrical insulator, but graphite conducts electricity. Explain why graphite can conduct electricity. 2 marks again. So it's got 3 electrons which move between the layers of atoms. Okay, 3 electrons move between the layers of atoms. If you are going to conduct electricity, you need to have either 3 ions or 3 electrons. That's the only way you can conduct electricity. Just remember that. Question 4. Describe, with the aid of a diagram, the metallic bonding present in metals. So for this, what you needed is to show your positive ions, okay, which I've done in blue, and your negative electrons. And since you're triple science, you should know that these are positive cations. Okay, positive cations. Cats make you happy, so they've got positive feel to them, if that helps you remember it. Now your diagram needed to show random movement as well, but it also needed these 2 labeled, so these 2 labels to the diagram. You could then also use words to help explain that, so I'll just move this over to the side and write the sentences which are required. So you need to say they are regular pattern of ions, tightly packed, there are 3 electrons, and number 4, hold structure together. Okay, so you can see here I've got the positive ions arranged in a nice order, and the electrons are a little bit random, moving around. This might, for some of you, might upset you or make you question previous diagrams that you've done where you've drawn solids as with all the particles touching each other. Okay, like this diagram down here, a solid. The thing to remember is these are diagrams which represent a complicated aspect of science. Okay, they aren't exactly how you would see them or view them if you could. They are merely a representation, and that becomes very important later on in the IB when you start to study things like theory of knowledge and how we know things. So this diagram that you've just drawn for the metallic bonding, you may think that these positive ions should be right next to each other, and in actual fact they are very tightly packed, as one of the marks is worth. But for the diagram's sake, you draw them a little bit further apart so it's easier to fit the electrons in. And just remember, it's a representation. It's not exactly how it actually looks. And following on from the diagram, use your knowledge of the structure of metals to explain why they are strong. So if they're strong, the forces holding the lattice together are strong. Tightly packed ions in lattice. Okay, 2 marks. Do always look at the number of marks and see what they're worth. Explain why they are malleable, and this is quite simply layers of ions as you've represented in the diagrams. Layers of ions can slide over each other. Okay, so that's mark 1, and slide over each other is mark 2. And then finally, as the blades of the helicopter rotate, heat produced in the joints is conducted away along the blades. Explain how metals conduct heat. And the free electrons take in heat passed on as electrons collide. So that's what the mark scheme wanted. When it says the electrons take in heat, what it essentially means is the electrons are going to start to move more, and they're going to pass that energy on as they collide into other electrons or as they collide into other ions. Okay, hopefully you did well. Feel free to review the video as you please. Thank you.